Hey everyone, ready for something pretty wild? Today we're going to dig into a new kind of language model. It's shaking things up in how we think about AI and like intelligence. And it's not about making AI spit out even more words. It's about getting it to think harder.
Yeah, it's a pretty big shift, like we're moving away from this idea that AI is just this word machine and more towards like AI as a thinking machine.
Yeah. And our guide for this whole deep dive is this research paper. It's called Scaling Up Test Time Compute with Latent Reasoning, a recurrent depth approach.
Quite a mouthful.
It is right. But stick with us, because this paper, well, it introduces a model that's just unlike anything we've really seen before.
Yeah, it throws a real wrench in the gears of how AI is usually done. Think about it, like when we solve problems as people, sometimes the answer just pops into your head, right? But other times you got to really stew on it before you say anything.
Mm-hmm.
And most of these language models out there, they're all about getting better at talking, like churning out text. But this this one's all about getting better at the thinking part.
Okay, I'm hooked already. So instead of just focusing on language generation, this model, it like prioritizes the thinking process. So how does that work?
Well, right now, a lot of language models, they use what's called chains of thought. Like it's like showing your work on a math problem. They explain their reasoning step by step in words. Okay, but these researchers behind this paper, they're suggesting that forcing AI to always explain itself in our language, like in human language, might actually be slowing it down. What if it could think more efficiently in its own language, like a language of pure information?
Whoa, that's deep. It's like we're assuming that AI needs to think like us to be intelligent, right? But what if it can be intelligent in a totally different way?
Exactly. And that's where this new model comes in. It's called the recurrent depth model. And it works in a totally different way than like the usual models. So instead of just adding more and more layers, which is how most models get bigger and supposedly smarter, right? This one, it uses a special recurrent block that's like a loop.
Okay, so instead of a straight line of processing, we have a loop. What's the advantage of that?
Okay, imagine a chef perfecting a recipe, right? They keep trying a different combinations of ingredients and techniques going around and around until they hit that perfect flavor.
Mm.
That's kind of what this recurrent book does. It lets information flow in this loop and it gets deeper with each
Oh,
cycle.
so it's like the model is thinking deeper and deeper with each pass through the loop. That's cool. I like that visual.
And this looping structure, it gives you some big advantages over the traditional way of building these language models. Like, first off, it doesn't need this special training data. A lot of models that are really good at complex reasoning, they need to be trained on data that shows them step by step how to solve problems.
Right.
But this one can just learn from standard text, which makes it way more adaptable.
Ah, so it's not just mimicking human problem solving, it's developing its own way of thinking?
Boom, you got it. And there's another big benefit efficiency. This architecture can do way more calculations per parameter than like typical models.
Hold on. Can we rewind for a sec? For the for the folks out there who aren't AI experts, could you explain what a parameter is?
Sure. Think of parameters as like the knobs and dials that control how a model processes information. So the more parameters it has, the more complex its brain is.
Okay.
But this new model is showing us that it's not just about having a ton of knobs and dials, it's about using them the right way.
So it's not just about the size of the model, it's about how efficiently it uses what it has.
You got it. And this efficiency thing, it gets even more important as we build these bigger and bigger AI
I
models.
bet. Now, I know this paper dives into a specific model that they built using this approach. Tell me about that.
Yeah, it's called Hugin 0125.
Human-A125. That's a pretty unique name. Where'd that come from?
So it's named after Hugin, which is this raven from Norse mythology, and it's known for being super smart and being able to fly all over the place to gather information. And the researchers chose this name because just like a raven, the model is surprisingly intelligent for its size and it can kind of like unfold its capabilities during testing.
Ooh, I love that. A small but mighty model like a raven. How does it actually stack up against other language models in terms of size?
Well, it's got 3.5 billion parameters, which sounds like a lot, right? But in the world of giant language models, it's actually on the smaller side. A lot of the big names out there have tens or even hundreds of billions of parameters.
So it's really punching above its weight class. And they trained this model on a massive data set, 800 billion tokens. Again, for those of us who don't speak fluent AI, what's a token exactly?
You can think of a token as like a piece of a word. So it could be a whole word or it could be just part of a word, like a prefix or a suffix. It's basically how we break down language into these bite-sized pieces that a computer can digest.
Okay, makes sense. So 800 billion tokens? That's a lot of language for this model to learn from.
It is, but building and training this model, it wasn't exactly smooth sailing. At first, their attempts actually led to the model's internal representation collapsing.
Wait, the model's internal representation representation collapsed. What does that even mean?
Basically, it means the model stopped thinking in a way that made sense. The way it was representing information internally got all jumbled up and it just stopped making sense.
Yikes. So what do they do to fix that?
They had to go back to the drawing board and tweak some things really carefully. They adjusted the model's architecture and its starting settings, which we call initialization in AI. It took a lot of trial and error to get Huygens-0125 to actually think properly.
Wow. Sounds like they were really pushing the limits with this new kind of model, but clearly it was worth it. What kind of performance did they see once they got it working right?
Well, it's still early days for this type of model, but the results are super promising, especially on tasks that involve math and code reasoning. Huygens-0125 actually did better than a lot of the bigger, more established models.
So it's like they gave this model a smaller brain, but it's using that brain way more strategically. And I bet the longer you let it think, the better it does right.
Exactly. Remember that circular information flow we talked about? The more times the model gets to go around that loop, the deeper it can dig into a problem. And this ability to keep getting better, the more it thinks, that's what makes this model so exciting for the future of AI.
This is blowing my mind. We're talking about AI that can improve itself just by thinking longer. What are the implications of that?
I mean, it means we might be underestimating what AI can really do by only focusing on how big it is. This research is showing us that how a model thinks is just as important, if not more important, than how big it is.
So it's not just about brute force computation anymore. It's about developing AI that can think strategically and efficiently. And this model has another really interesting feature. It's got some advantages that other models have to be specifically trained for.
That's right. It's almost like this new architecture comes with these natural talents that other models have to work really hard to learn.
Okay, you can't just leave me hanging like that. What kind of advantages are we talking about here?
So one of the most interesting things is it's called adaptive compute. Remember how we said the model can figure out how much thinking it needs to do for a problem?
Yeah?
Well, this means it can actually stop recurring early if the answer seems obvious, and that saves time and energy.
Oh, so it's like it knows when to stop and think, okay, I've got this, instead of overthinking things. That's a pretty handy skill for anyone, human or AI.
Exactly. Like it's got an own built-in efficiency expert, and they actually tested this by setting up this simple rule. If the difference in the predictions between two thoughts in a row falls below a certain point, the model just stops thinking about it.
Oh, that's clever. It's like it's saying, okay, I've thought about that enough. I'm good with my answer. I can see how that would be super useful in real-world stuff where speed matters.
For sure. And the researchers, they found that the model naturally figures things out faster on easier tasks like high school math problems, while it takes its time on tougher questions like moral dilemmas.
Wow, so it's not just blindly churning away. It's adjusting its effort based on how hard the problem is. What other hidden talents does this model have?
Another big one is memory sharing. Think about how we remember things. Sometimes we try to remember every little detail, and that can get overwhelming.
Right.
But a lot of times we just need the main points. Traditional language models, they have this thing called a KV cache, and that's where they store information about the earlier parts of a text or conversation.
So like the model's short-term memory.
Exactly, but this can eat up a lot of memory, especially for really long chunks of text.
It's like trying to remember every little thing from a super long rambling story. You just get overloaded.
Totally, but with this new model, they found that they could share the KV cache between the different layers of the model without messing up the performance.
Oh, interesting.
So they were basically making the model use its memory more efficiently.
It's like the model is learning to be more picky about what it remembers and just focusing on the key stuff. That's a good skill to have these days with so much information flying around.
Definitely, and they didn't stop there. They also explored something called zero-shot continuous chain of thought. Instead of starting each thought from scratch, they let the model use information from the thought before.
So it's building on its previous thoughts, creating a more continuous flow of reasoning. It's like it's having a conversation with itself, getting deeper with each back and forth.
Yeah, exactly. And they found that this simple tweak actually made it so the model needed fewer thinking steps to get to an answer.
So not only is it thinking deeper, but it's thinking smarter too. This is seriously impressive stuff. Okay, now I'm really curious about that benefit you mentioned that speeds up the whole text generation thing.
Oh, you're talking about self-speculative decoding, right? It's a pretty slick way to make text generation faster without sacrificing quality.
Yes, tell me all about it.
All right, so with like the usual language model, speeding up text generation usually means using a separate, smaller model to generate a quick, like a draft version of the text. And then that draft gets polished up by the main, more powerful model.
So it's like having a team of writers, one who comes up with the rough ideas and another who makes it all fancy.
That's a great analogy, but these researchers, they found that with this recurrent depth model, they could get that same draft and refine effect without needing a whole other model.
No way. It's like the model can switch between a fast draft mode and a deep thinking mode all on its own.
You got it. It's like it's streamlining its own creative process. It can quickly whip up a draft using fewer thinking steps and then go back and refine it with more thinking if it needs to.
This is incredible. It's like this model's just full of surprises. It's not just getting better at reasoning, it's also becoming more efficient, more adaptable, and even more creative.
Yeah, it really flips the script on what we think AI can do. And remember, this model is still kind of small compared to some of the giants out there. Imagine what they could do with this architecture if they scaled it up.
I know, right? The possibilities are endless. Okay, let's talk benchmarks. I know they compared Huggin-0125 to some of the big names in open source AI. How did it stack up against the competition?
Well, we got to remember that most of those other models, they're built using a different approach, the traditional fixed depth transformer. So it's not always a fair fight.
Right, it's like comparing a race car to a sailboat. They're both built for speed, but they get there in totally different ways.
Exactly. But even with that difference, Hubin 0125 did amazingly well. Remember, it only has 3.5 billion parameters, but it was going toe-to-toe with models that have way more, like tens of billions of parameters.
It's like David versus Goliath AI edition. So tell me, what were some of the big takeaways from these benchmarks?
Well, on some general language tasks, it did about as well as the first version of a model called OLMO, which is pretty good considering its size. But where it really shined was in tasks that involved math and coding.
Ah, those areas where you need deep logical thinking. It sounds like this model was made for that kind of stuff.
And it consistently beat almost all the other open source models in those areas. In fact, in math reasoning, it almost matched the performance of the much larger later versions of OLMO.
So it's really showing that this recurrent depth approach could be a total game changer for AI, especially in fields where you need complex reasoning.
Yeah, that's what it looks like. And remember how we talked about the model's performance getting better with more test time compute?
Uh-huh.
Well, that was super clear in the math and coding benchmarks.
The longer it thought, the better it got. So is this the key to unlocking real artificial intelligence? Is recurrence the missing piece of the puzzle?
It's a really interesting thought, but it's important to remember that the researchers were very open about the limitations of how they trained the model. They were training a big model on a brand new architecture with limited time to actually do the training.
So they were working with some constraints. What kind of limitations are we talking about here?
Well, for one, their training data set, while it was large, was still way smaller than the data sets used to train some of the industry giants they were comparing it to.
So it's possible that with more data, a better training process, and even more powerful computers, this model could do even better.
Absolutely. They're basically saying they were just getting started with what this approach can do. It's like they've given us this glimpse into a whole new world of AI, and we're just beginning to explore it.
That's incredibly exciting. Now, one thing I thought was super cool about this research was how they really tried to understand what's going on inside the mind of this AI. Can you tell me more about that?
Yeah, remember, the model is doing all this thinking in its own internal space, not in words. So the researchers wanted to see what that thinking actually looks like. They used a technique called visualization to make a kind of map of the model's internal activity.
So they were creating a visual representation of the model's thought processes. Did they find those swirling patterns of data I was picturing earlier?
Not exactly swirling patterns, but you're on the right track. What they found was that different concepts are showing by different patterns of activity within the model.
Okay, so I'm imagining these complex dynamic patterns that shift and change as the model thinks.
That's a great way to picture it. They found that some concepts are represented by these stable points of activity, while others are shown by these complex multidimensional orbits. It's almost like watching a dance of thought unfolding in this multidimensional space.
That's such a cool way to describe it. And remember how they said the model has this kind of internal timer? Did they see that in the
Oh,
visualizations?
yeah, they did. They saw that sometimes the activity would drift in a certain direction over time, which could mean the model is keeping track of how long it's been thinking.
It's like the model is developing a sense of time within its own thinking. That raises so many questions. Like, if we can see these thought patterns of AI, does that mean we're getting closer to understanding its mind?
That's a huge question, and I don't think we have a good answer to that yet. But it definitely opens up a whole bunch of new possibilities for how we study and interact with AI.
It's really, really remarkable. And there's one more thing I want to ask you about before we move on. This whole idea of AI thinking in its own language, a language we don't totally get, is kind of mind-blowing. But doesn't that also make things trickier? Like, if we can't understand how it's thinking, how can we make sure it's thinking ethically?
That's a super important point, and one that the researchers talk about in their paper. As we build these more and more advanced AI systems, we need to be really careful about how to make sure they're in line with our values, even if we don't totally understand how they work on the inside.
It's a challenge for sure, but one we have to face head on. We're heading into uncharted territory with AI, and we got to prioritize ethics and responsibility as we explore this new frontier.
Yeah, it is a challenge, but we can't just ignore it. As AI gets more and more complex, we need to start thinking differently about how we work with it and how we can be sure that its development is good for humanity?
Absolutely. It feels like we're standing at the very beginning of a whole new era of AI, one that's full of potential, but also one that needs us to be really thoughtful and responsible.
Totally. And this paper, with its focus on latent reasoning, really shows that shift? It's a reminder that AI isn't just about copying how humans think, it's about exploring completely new ways of thinking.
It's like we're discovering that intelligence doesn't have just one definition. It can show up in different forms, even in ways we might not totally get.
Exactly. This research is pushing us to broaden our understanding of what intelligence can even be.
Okay, so we've covered a lot in this deep dive. We've talked about Norse mythology and visualized these thought dances, and we've even thought about the philosophical questions of AI consciousness. I gotta admit, I'm still processing it all.
Yeah, it's a lot to take in. But let's try to break it down to the most important stuff.
Okay, so if you had to pick just one thing, what's the one thing you want our listeners to walk away with from this episode? Why should they care about a language model that thinks in circles?
That's a great question. I think the big takeaway here is that the future of AI isn't just about making models bigger. It's about building models that think in new ways.
So it's about quality over quantity when it comes to how AI thinks.
Exactly. And this recurrent depth architecture with its ability to think deeply and do it efficiently in its own language is a really great example of that.
It's almost like we're moving past the era of AI parrots, those models that are great at copying human language, and we're entering the era of AI thinkers, ones that can figure things out in their own unique ways.
I like that. That's a great way to put it. And that has huge implications for what's coming next. Imagine a world where AI can not only understand and respond to what we tell it, but it can come up with its own solutions, its own ideas, its own creative impressions.
That's both exciting and a bit scary. Makes you wonder, what will our role be in a world where AI can think for itself in ways we don't fully understand?
Yeah, that's the million-dollar question, isn't it? It's one we need to be thinking about right now as AI keeps advancing so quickly. This research really highlights the fact that we need to be having these conversations, exploring the ethical and philosophical questions, along with all the technical advancements.
Totally agree. It's not enough to just be wowed by the cool tech stuff. We got to engage with the bigger picture, too. This deep dive has definitely given me a lot to think about. I'm curious, what are your hopes for the future of this kind of AI? Where do you think this research could lead?
I think this research could lead to AI that's more adaptable, more creative, and better at solving those really tough problems that we as humans have trouble with. Imagine AI that can help us tackle climate change, come up with new medical treatments, or even explore the universe in ways we can't even dream of right now.
Those are some really inspiring possibilities. It sounds like we're on the edge of this new era of collaboration between humans and AI, where we can work together to solve some of the biggest challenges facing the world.
I hope so too, and I think this research is a huge step in that direction.
This has been an amazing journey. I'm leaving with a whole new understanding of what AI can do. Thanks for guiding us through this awesome research.
It was my pleasure. And to everyone listening, remember the world of AI is always changing. Stay curious, keep exploring, and never stop asking those big questions. You never know what incredible discoveries are waiting for us.
Well said. That's the perfect way to wrap things up. Thanks to everyone for joining us on this deep dive. We'll be back soon with another mind-bending exploration of the cutting edge of science, technology, and human knowledge. Until then, stay curious, everyone.